Scientists have spent 140 years studying Earth's climate cycles. They were certain they understood what they were looking at. Then, Grok AI ran the numbers, and Earth's climate history suddenly looked less like science and more like a blueprint. The pattern was too consistent, too deliberate to dismiss as random natural occurrence. The scientists who reviewed the findings went quiet, because whatever left this pattern behind was not reacting to Earth, it was controlling it. So the question is no longer whether the pattern is real. The question is who or what has been controlling it all along.
The first reconstruction. The first major warning sign appeared when Grok compared two climate events that should have had nothing in common. The first was the Paleocene-Eocene thermal maximum, a violent global heating event that occurred 56 million years ago. During this event, massive volcanic activity released enormous amounts of carbon into the atmosphere. The oceans turned acidic, deep-sea species collapsed, global temperatures rose by several degrees in a short geological interval, making large regions nearly unlivable. Grok then examined the late Pliocene warmings, which took place during the end of the last ice age within the past 100,000 years. A warming in this context means a period when Earth's average temperature rises rapidly instead of slowly shifting over thousands of years. During these episodes, the ice sheets covering North America and Eurasia fractured and released sudden floods known as meltwater pulses that raised sea levels at terrifying speed. Coastlines drowned, entire valleys vanished underwater. Many large animals, such as mammoths, giant ground sloths, saber-toothed cats, and woolly rhinoceroses, disappeared in what appeared to be a chain reaction of starvation, habitat loss, and sudden climate shock. Some regions experienced temperature jumps within a human lifetime, forcing early humans to abandon their lands as storms intensified, food chains broke apart, and environments shifted faster than any society could adapt. These two events came from completely different causes. The ancient heating was driven by volcanic carbon released from huge eruptive zones called flood basalts. These eruptions pumped so much carbon into the atmosphere that the planet entered a runaway heating phase. In contrast, the Ice Age warmings were triggered by changes in Earth's orbit that altered how much sunlight reached the surface. Scientists had always assumed these events were unrelated because their triggers were so different. But Grok revealed something that overturned that belief after processing millions of data points from both events. The AI rebuilt the temperature history of each, one step by step. For the Paleocene-Eocene event, Grok began by feeding in temperature data extracted from ocean sediment cores, which contained chemical markers showing how warm the water was when ancient microorganisms lived. It combined these with carbon isotope records that reveal how much carbon entered the atmosphere. For the late Pliocene warmings, Grok used ice core data showing past temperatures, greenhouse gas levels, and dust concentrations. It also used ocean sediment records that track water temperature and meltwater pulses released when the ice sheets broke apart. Each dataset created a continuous timeline showing how fast or slow the planet heated during each period. Grok then converted these timelines into temperature curves. A temperature curve is a line that shows how quickly the planet warmed over time. The AI set both curves on the same scale, meaning it matched the years, the temperature units, and aligned the starting point so the comparison would be exact. This allowed the team to see not just the beginning and end of each warming, but the entire shape of the heating process. Once the curves were aligned, something shocking happened. In both events, the warming began with a gentle rise. After that rise, both curves bent sharply upward at the same point, meaning the rapid heating phase began after the same amount of time. Both curves then climbed at nearly the same speed, showing that the planet heated at the same rate, even though the triggers were completely different. Both showed warming rates between 0.02 and 0.03 degrees Celsius per century during the rapid acceleration phase. Finally, both curves flattened at almost the same temperature level, marking the point where the heating stopped. When Grok placed both curves directly on top of each other, their outlines nearly erased each other. All four phases matched between the two events, even though they occurred 55 million years apart. Several researchers froze when they saw the display.
Two events driven by completely different forces were following the same step-by-step pattern with the same timing and the same limits. It looked less like random climate behavior and more like the planet was following a preset sequence. The match was far too tight to be a coincidence. This forced Grok to ask a deeper question. It needed to find out whether these repeating signals were regional events or signs of a global pattern. The system began its search with the most violent moments in Earth's history. It turned toward the extinction events themselves.
The 5 mass extinctions. The first scene Grok revealed was the Ordovician Silurian extinction, a catastrophe triggered by a sudden global freeze. This freeze began when massive volcanic eruptions deposited huge amounts of rock and ash that increased the rate of weathering on land. That weathering pulled carbon dioxide out of the atmosphere much faster than normal, which caused the planet to cool sharply. Nearly 85% of marine life vanished. Grok shifted to the late Devonian extinction, a long crisis pushed forward by repeated environmental shocks. Expanding land plants released nutrients into rivers. These nutrients washed into the oceans and created large dead zones where oxygen disappeared. Coral reefs collapsed. River systems turned stagnant and toxic. Giant armored fish such as Dunkleosteus vanished. About 75% of species were lost. The room grew tense when Grok opened the End-Permian extinction, the Great Dying. This collapse was driven by massive volcanic eruptions in Siberia that released enormous volumes of carbon dioxide, methane, and sulfur gases. Forests burned, the oceans turned acidic. Up to 96% of marine species died. Many early reptile and amphibian groups disappeared. The AI then examined the End-Triassic extinction, which began when violent volcanic eruptions tore open massive rift zones across the planet. These eruptions released huge amounts of carbon dioxide and toxic gases into the atmosphere, driving rapid warming and triggering one of the most destructive collapses in Earth's history. Finally, Grok reached the Cretaceous-Paleogene extinction. A large asteroid struck near the Yucatan Peninsula. Shockwaves, fires, and global darkness followed. Dust and toxic gases filled the sky. Non-avian dinosaurs vanished. 75% of species died. Only after showing all 5 disasters did Grok reveal the part that stunned the room. When the AI stripped away the differences between each extinction and kept only the physical signals behind them, the same hidden structure appeared every time. It did not matter whether the collapse began with freezing volcanic eruptions, asteroid impacts, or slow climate swings. Once the planet was pushed past its first critical point, it entered the same chain reaction. The first stage always began with a sharp rise in greenhouse gases, which are heat-trapping gases in the air, such as carbon dioxide and methane. Grok showed that each extinction crossed this rise at nearly the same proportional rate, even when the original trigger was completely different. This pushed global temperatures upward so quickly that ecosystems could not adjust. The second stage appeared when the oceans lost their ability to mix. Grok displayed oxygen maps from different eras and showed the same pattern forming again and again. Warm water stayed at the surface, cold water stayed trapped below. Oxygen stopped circulating. Huge sections of the ocean turned deadly in the same way across every extinction, even though the continents and sea levels were never the same. The third stage emerged when the final temperature surge hit. Grok highlighted the same steep climb in every dataset. Once this surge began, ecosystems already weakened by heat and oxygen loss collapsed in a rapid chain failure. Forests, food webs, and entire species groups unraveled at nearly identical points on the curve. The room went silent because Grok had shown something no human had ever proved before. Earth did not unravel differently each time it was stressed. It broke in the same order through the same stages, as if the planet were running a script that reactivated whenever conditions crossed the same invisible threshold. Then, Grok exposed a disturbing timing pattern that strengthened the feeling that something was wrong.
4 of the 5 mass extinctions occurred within a narrow window of 145 to 155 million years apart. This tight spacing was not normal. Events driven by deep Earth processes such as mantle plumes rarely behave with such precision. Mantle plumes are rising columns of extremely hot rock that can cause long-lasting volcanic activity. Their eruptions usually vary by tens of millions of years. Groq showed that the extinctions did not drift in timing the way mantle plume events normally do. Instead, they aligned far more closely than expected, which meant there was a consistency in the collapse intervals that natural geological behavior could not easily explain. Another detail made the entire team uneasy. Groq compared the end-Permian and end-Triassic extinctions. These disasters happened during very different continental arrangements. During the end-Permian, all of Earth's land masses were joined together into one giant continent called Pangaea. Every major continent was connected as a single land block with one enormous coastline. By the time of the end-Triassic, this giant continent had begun to split. New cracks opened in the land. Ocean water filled these rifts. The single landmass started dividing into separate pieces that would eventually form the modern continents. Even with these major differences in Earth's layout, the atmosphere in both eras reached almost the same buildup of sulfur aerosols. Sulfur aerosols are tiny particles